Hi everyone, welcome to another SEGI Evening Schools sessions brought to you by SEGI Groups of Colleges. My name is Dr. Ida Fahani and I am the moderator for today's sessions. Welcome to this live webinar titled Cyber Physical Systems, How Engineering and IT Professionals Change the World, brought to you by SEGI Group of Colleges. Before we begin, I'd like to do a quick tech check. Can everyone hear and see me clearly? Type yes if you can. Thank you, everyone. For those who just joined in, I welcome you once again to this live webinar titled Cyber Physical System, How Engineering and IT Professionals Change the World. My name is Dr. Ida Fahani and I will be your host for today. A quick briefing to everyone before we start. Our sessions today should take approximately 45 minutes. During the session, we encourage you to type your questions in the comments, and our speaker will try to answer your questions during the Q&A sessions at the end of the webinar. We will also like to inform everyone that this webinar is recorded and will be used by SEGI University and colleges and its subsidiaries in the future. Before we proceed, can everyone type in the comment section and share with us where are you connecting from? As I understand, there are registrations from all over Malaysia and other countries. Is everyone ready for the webinar? If you are ready, press 1. Okay, So our topic for today is cyber-physical system, how engineering and IT professional change the world. And our speaker for today is Mr. Eric Lim. Let me share with you a little bit about our speaker today. Mr. Eric Lim has been in the test and measurement industry for the past 9 years with a vast hands-on experience in high-speed digital data test and measurements, signal quality assurance, test automations, solution development, and project management. He conducted numerous technical training to the engineers, lecturers, researchers, and students in electronics industry across Southeast Asia regions, especially in electronic test and measurement as well as IoT related topic. Without further ado, let's welcome our speaker, Mr. Eric. Over to you, Mr. Eric.
Hi, thank you, Dr. Ida. So good afternoon, everybody. Thanks for joining this session. My name is Eric, application consultant from TechMart Group. I've seen some of the live comments. Some are from this region, some are from Subang, and we even have participants from Philippines. So welcome. But sad to say, I couldn't speak Tagalog today. All right, I'm really glad to be part of this webinar series by Segi College. And to be frank, I'm currently present in Segi College in Subang campus. To be frank, I couldn't feel better talking to undergraduate students or postgraduate students, as well as the lecturers, because you guys reminded me about the great memories I had in the campus back then. So yeah, okay, let's get started. Today we are going to talk about the cyber physical system. Simply put, how do we digitize a physical world and some of the challenges the industry is facing. And of course, we will table some solutions on how to overcome these challenges. And from my understanding, we have a mixture of participants today, in between students, lecturers, and working adults. So working adults can be from engineering industry or non-engineering industry, and even in engineering, there are IT industries or electronics industry to be particular. So regardless of which industries you're coming from, today the content, the webinar will make it generic to cater to most of the audiences over here. And of course, this is a collaboration with Segi College. So we'll talk a little bit more on the challenges to the students, the challenges the lecturers will be facing. Next, doctor. Okay, so this is, can we go back to last slide? Yeah. So this is something, a norm to all of you. Whenever you have, say you have a date, you have an appointment, you want to make a reservation in a restaurant, for example, we will quickly, if you don't know the contact, okay, we will quickly sort up to our phone to Google, and you will type, say, a McD nearby, or cafe nearby, or Western restaurants nearby, or pizza a house nearby. And when you have the result, most of the time, the information that is available to us are, say, the addresses, the map, the location, the telephone number. And if you scroll further, probably you will see a commands, a review of the restaurants. And I wish to draw your attention to this bar chart on the right-hand corner of the slide. From here, you can probably tell, let's say, the peak hour for these restaurants, for example, is from say 12 p.m. to 2 p.m. That's the peak hour. And it is less busy during the day at say 2 p.m., 3 p.m., all the way to dinner time. So now my question is, who is the one actually creating this bar chart? Okay, since we have an interactive session over here, if you think the restaurant owner is the one typing this bar chart, creating this bar chart, please give me a 1. If you think the restaurant owner is the one who type it out, please give me a 1. And if let's say you think, no, couldn't be the restaurant's owner, probably the public, someone else like you and I. If I am kind enough, I updated this bar chart. So if you think the public is the one typing this out, give me a 2. Or maybe if you think otherwise, there are some other answers. Probably Google do it. I don't know. Or some other answers. Give me a 3. Let's have a few seconds. 1, 2, 3, 4, 5. So what do you think? Is the owner of the restaurants who is the one to put up this bar chart, or is the information from public where anyone can edit this bar chart, or Google is the one to put up this? So this chart is actually it's so common to us, but there are times we take it for granted. We don't really appreciate like where is this information coming from. So, well, okay, I'm seeing answers. Right. Some of you got it right. In fact, yes, it is not from the restaurant owner. It is not from the public, but Google is the one cranking data out of the available resources to Google, and they are the one who put up this information online. So try to think deeper. Who is the one that is actually contributing to this data? It's actually you and I. If you and I are, say, Google owner, Android phone owner, Android phone user, we use this Google Map. Google have knowledge, in fact, of how the population, how many persons is currently locating exactly at this restaurant I'm searching. So by looking at past data, that's how they crank out the bar chart. So if you think cyber physical world, or in short IoT, is something happening in the future, then think again. No, it is not. We are actually living in the future. Next, doctor. Okay, so take the restaurants as the case study as an example. It is a very typical IoT applications. Yes, we know that. But what are the sensors over here? Very obvious, we are contributing our location. So the GPS sensor is the sensors. And what are other elements we are contributing to Google? So we are contributing the location. We are contributing the time information to Google. And the information will be stored in the internet, probably somewhere in their server in regions nearby. So in short, if you talk about cyber physical or IoT, it is about connecting billions of devices to the internet. That is what you and I are actually doing right now. And of course, there are 1,001 of benefits of doing so. The convenience gained, like the one you and I are enjoying. We know exactly what is the peak time of the restaurants and when is the non-busy or non-peak time, and you can visit at the exact time that you preferred, so that you don't have to wait in a long queue. So yes, convenience gained is part of the benefit. Of course, if you talk about some of the other IoT applications, say smart meter, smart water meter, we are doing it for cost efficiency objective. There are cases where we do it for market efficiency, but they are at the same time comes with disadvantages. Privacy is one. Okay, so we'll talk more about the good and bad of IoT in a short while. Doctor, next. Okay, so this is a rather old slide. In fact, when I got this invite, I ran through some of the materials, and I realized this slide prepared, say, 3-4 years ago. It's very interesting. 4 years ago, we predicted at year 2020, which is right now, there are more than 30 billion devices will be connected. Cisco predicted 15 billion, and IHS Technology predicted 95.5 billion. And I remember back then when the president of Samsung Electronics, when he announced that 90% of all Samsung products will be IoT enabled by 2017 and 100% by 2020. Back then, it was a big hoo-ha. Like, wow, can you imagine a fridge with internet enabled, internet connectivity enabled, IoT enabled washing machine? Fast forward to today, I don't really know what is the percentage Samsung is achieving, whether or not it is 100% IoT enabled. But true enough, if you and I pay a visit to, say, any of the electronic shop, electronic compliance shops around, it would be a norm to see a washing machine, robots, a vacuum cleaner, even a fridge that is internet enabled. You can control your washing machine exactly when to turn it on and when to turn it off. So yeah, again, it proves that we are actually living in the future. Doctor, next. Okay, so let us take a closer look at what are the key components that is available, that IoT framework is consists of. So if you take any of these IoT applications, these are the 5 components we will be looking at. At a very low level, we have something called the things. In other words, they are the sensors. They are the sensors, they are the actuators, they are the meters, they are the smart devices. Take, for example, a fridge, a washing machine, a vacuum cleaner, your smartwatch, even your phone. Those are the things. So in short, we call it everything. Everything that is internet enabled. So at this layer, this is the thing. And at the second layer, because we have the gateway. At the second box next to sensor, we have the gateway. And in between sensor and gateway, we have the green color symbol, which is called the connectivity. So if you look at the symbol at this slide, the one with the purple color symbol is the thing, or we call it the sensors, or actuators. If the yellow color is the gateway, then the green color is the connectivity. So connectivity, it can be wireless connectivity, it can be wired connectivity running at different protocols. So long they can pass the information from the sensor all the way to the cloud, then we will take that into account as a part of the connectivity. And moving forward, you have the blue color icon that looks like a cloud. Indeed, it is the cloud. This is where we store the sensor informations. We keep them secured, and also the dashboard or the applications. This is where the applications, it can be web applications or cell phone applications, iOS or Android applications. They will be connected to the cloud to draw these sensor data and make sense of it. So, in short, in any of the IoT applications we are talking about, they are commonly having these 5 elements. The purple, we have the sensors. The yellow, we have the gateway. And in between gateway and sensor, we have the connectivity. And of course, in between gateway and the cloud, there is another connectivity. And then we have the blue color icon, which is the cloud, to store all the information from the sensors. And lastly, we have the orange color or the red color icon, which is the applications. And in this case, it isn't limited to cell phone applications, but it can be anything. It can be a dashboard, it can be a web applications, or it can be a cell phone applications. Okay, let's move to next one. So again, these are the 5 core elements we will be talking about. And probably you will be asking like, hey, well, why are we actually needing the gateway? Why can't we just send sensor data all the way to the cloud? Why are we needing the yellow box, the yellow icon, which is the gateway? So gateway, most of the time, it acts like a middleman in between the sensor and the cloud. So try to imagine if, let's say, I were to send the sensor data all the way to the cloud. My sensor has to be, say, Wi-Fi enabled, or 3G, 4G, or even 5G in the future enabled in order to connect all the way to the cloud. And there is a downside of it, which is the power efficiency. So if you connect, say, a temperature sensor all the way to the cloud with Wi-Fi connectivity, the downside is you may need to change the battery of the sensor very regularly, say once a day, or maybe twice a day. So that is not what we want. So in this case, we are putting a gateway right in the middle so that we can have a more power efficiency connectivity in between the gateway and sensors. And then from sensors and from the gateway onwards, it will no longer be battery powered, but more on AC powered. So we don't have the power consumption concern. Okay, let's move to a few case study, Doctor. Now take a look at this case study very quickly. Let us do this exercise together. So in the past, we talked about the 5 core elements of IoT. We have the sensor or the things in the purple color symbol. We have the yellow color symbol, which is the middleman, or we call it the gateway. And in between the gateway and the sensors, or in between the gateway and the cloud, we have the green color, which is the connectivity element. And lastly, we have the dashboard or the applications, or simply put, we call it the application layer or the application component. So these are the 5 core components that makes up the IoT ecosystem. Now, take this smart street light management system as an example. If we were to identify the things, it will be, say, the lighting system or any sensors that we place on top of a street light. It can be, say, wind sensor. It can be a humidity sensor, a temperature sensor, even light sensor to sense, to turn on the light to turn off the light during the daytime and turn it on at the night time. So those are the things. And there are probably a gateway somewhere nearby. So for example, within a suburb area or within, say, every 20 lampposts, there will be a gateway. And the gateway, I suppose it will be a 3G, 4G enabled so that we can transmit data all the way to the cloud. And in between the gateway and the lamppost, we are using what we call that, a power efficient connectivity. A few examples are, say, Zigbee, Sigfox, LoRa. These are good candidates of power efficient, low range connectivity. And of course, the application layer, we have, say, the dashboard on the monitoring center. That is where the personnel will be sitting in the control room, turning the street light on and off, or doing predictive maintenance, or anything that is useful to the authority. So let's take a look at the next example, Doctor. Okay, very typical example. I think a few shopping malls in Subang area or in KL area, they are implementing this, a smart parking system. So again, what are the things? It can be a camera, it can be a sensor sitting right on top of the parking lot to check if that particular slot is taken. So those are the things. And we know in between thing, instead of connecting sensors all the way to the cloud, we have a gateway as the middleman, which is the yellow color icon. And the green color element or the connectivity element, it can be running in say, wireless, Zigbee, or even Wi-Fi, or they can even be a wired connectivity because it is within a parking lot, right? And then in this case, after gateway, we will be storing the information in the cloud. And from the cloud, that is where we pull the data down and display it on a dashboard, like the example in the diagram. So a few key benefits, of course, the conveniences, we reduce traffic congestion for traffic control, and you name it. There are so many conveniences. Okay, now, let us conclude on this. Doctor? Again, to reiterate, we have 5 elements. First, we have the purple color icon, which is the things. The things in this case can be any sensors or actuators. And the second element is the connectivity that sits in between the sensor and the gateway, or in between the gateway and the cloud, which is the 4th element. And the 5th element, we have the application. And in this case, it can be a smartphone, a cell phone applications, or it can be a web app, a dashboard on your SharePoint, or it can be a display, LED display, 7/7 display on a parking lot. Okay, now, done with the overview, let us move on to some of the challenges. Okay, what is the time now? So time check. We have 10 more minutes. Okay, so let us take a look at some of the challenges, the real challenges the industry is facing. Can we go next? So earlier on, we talked about the disadvantages of, one of the disadvantages of IoT is mainly on the privacy concern. So yes, indeed. For example, if I am using Google Map, for the convenience I'm actually surrendering my location to Google. So Google knows exactly where I am. And of course, I have a control over this, whether or not to to surrender or to give contribute my location information to Google. But most of the time we are giving in because of the convenience we are getting. So that is the one concern the industry is trying to tackle. And say, for example, if you have, say, a temperature sensor, you have a smart thermostat at home, or smart switch at home, the service provider know exactly what time you are actually at home. So that poses another privacy concern from IoT applications, the convenience of IoT applications we are gaining. And other than that, of course, there are some a network concern like a replay attack, or man-in-the-middle attack, or denial of services. So a few forms of attacks, like for example, somebody hack into the system and manipulate the data that is transmitting from my sensors all the way to the cloud. Or they are doing a DOS where the source is made unavailable. That means I couldn't connect to the cloud. I lost connectivity to the cloud. All sorts of security issues. And these are commonly functionality issues, and we don't have a right answer to it. The industry is working so hard to overcome it. Next. Next, we have this, what we call the design issue. So since we are talking about IoT, and I'm coming from electronics background, so it is worthwhile for us to take a closer look at some of the challenges the electronic engineers, to be exact, they are facing when they are developing IoT applications like a smart watch, for example, or smart water meter, for example. So the problem is, like we learned in a past case study, that IoT applications are commonly battery powered, right? And in order to preserve the battery, we have to make sure the current consumption is very low. So you try to look at the right-hand side, the top right-hand side corner of the diagram. The yellow color waveform, that is the current consumption plot with the instrument called oscilloscope, if you are not from electronics background. So from here, we can know exactly what is the current consumption of the device in, say, for example, the active state, which is having the highest level of current consumption, and during the standby stage, or even at the sleep state. So from here, we can know one thing is that the IoT devices or IoT sensors, they are built in such a way that they sleep most of the time. How I wish I can work like an IoT sensors. Like I work only once a day and I sleep for the rest of the months. That is exactly what is happening to, say, a temperature sensor or smart water meter, because the utility company or a utility supplier, they don't have to read utility bill or water meter very frequently. They probably read it once a month, or they read it once a day at most. So for the rest of the day or for the rest of the month, most of the time this sensor or the smart water meter is actually sleeping. So in this case, since the IoT devices is sleeping most of the time, the current consumption during the standby state or the sleep state matters to us. And we are talking about so many sensors you can see from the left-hand side. Let's go around very quickly. We have the position sensor. We have the The one on the, let's start from the 12 o'clock. We have, say, from 1 o'clock to 3 o'clock. Those are the smart home sensors. And we have vibration sensors, chemical sensors, or flow sensors. Those are the sensors commonly used in the smart factories. Then we have force sensors, also for smart factories. We have leakage, level detection sensor for smart factories as well. And we have acceleration and say ambient light, optical sensor. Those are, I would say, frequently used in smart city applications. So when you look around all the sensors, one common trait is they're all battery powered. Also, which is why the battery life, how to preserve battery life become so important, so crucial, and that poses a challenge to the engineer. Now, go back to the graph over here. If you go slightly deeper into the technical, if you want to measure current consumption during the active state, that shouldn't be a problem. It is something easy to measure because if you are drawing current, all we need to do is just to tap the IoT devices with one of the instruments that you can see at the right bottom corners, be it a multimeter or an oscilloscope or a power analyzer. So to measure current consumption on the active state is not a tough job, but the tough one will be to measure current consumption on the sleep state, where the current consumption is so low, so close to zero. So this is the new challenge electronic engineers are facing. They need instruments at a very clean environment or very low noise in order to measure the current consumption correctly. Next. So these are some of other instruments that is available in the industry. Current consumption, we have just covered. For energy efficiency, yes, we have solutions to measure that. But not only that, try to recall back the green color icon we covered a while ago. The connectivity. If let's say I were to produce a smart watch, for example, running on Bluetooth 5.0, before I mass produce this smart watch, for example, I need to measure. I need to know exactly what is the channel power, what is the occupied bandwidth, and the instruments I'll be using is probably a signal analyzer with sophisticated antennas and softwares. So these are the available solutions from Keysight Technologies to the industry. And a part of hardware, Doctor, can you move on to next slides? Okay, so a part of hardware solutions, of course, if you think of smart factories, the place where our electronic graduates will be working on in the future, we have a smart factory or the buzzword lately, Industrial Revolution 4.0. We do have a solution on that. So if you think IR 4.0 is again something in the future, we are not there yet, then think again. Keysight Technologies, they already came out with a solution for IR 4.0 or for the smart factories, and they are actually delivering this to the customer. So let us take a quick look on what is this software capable of doing. Can we go next? We are running short of time. Take this for example. The software is called Path Wave Manufacturing Analytics, but I want to draw your attention to the icons next to the big data keywords. So try to imagine if you have a design house, research and development center, say in the United States, and for cost reason, for a supply chain reason, instead of building the factory in proximity to the design center, probably we have our factory set up in the other side of the globe, closer to, say, the supply chain, or somewhere with more cost-effective labor. So in this case, very often the engineers in the design center or the R&D engineers, they need to know exactly what are the measurements, the test and measurement results, how does their product performing in the production line. This software is built exactly to tackle this problem. So if you look at the icons over here, what are the big data we can tap into? We can measure, of course, the measurement data, the test measurement data, the metadata, the event data, the energy data, or even the sensors that is placed along our production line or the conveyor belt. So we are actually building a digital mirror of the factory, where the R&D engineers across at the other side of the globe can know exactly what is happening in the factory itself. So if you look at the on the top side of the arrow, we have this iceberg. The main purpose of this software, of course, is to discover whatever that is buried below the iceberg, like the hidden symptoms. They do predictive anomalies. This is what the software is capable of doing. Let us move quickly because of the time concern. In next slide, you can see exactly an example of the GUI of the software, where, say, for example, at the top right image, the green color, for example, are the factories that is available from this dashboard. And if you click at each of these green dots, you can view data, live data from the dashboard. So all these are made available thanks to the technology, the IoT technology, or the cyber physical technology. And next, this is also one of the example that is very popular recently amid COVID-19 pandemic, where social distancing is a new norm. So when we talk about new norm, we have been hearing about this keyword over and over again lately. So if it is a new norm, that means very soon or from now on, it is a common practice for the students to run their lab activities from home. So just to share with you one of these solutions that is available, where students can, at their own pace, sit at home. All they need to do is just to log into the admin PC. So if you take a look at the box in the middle of the slides, the blue color is the remote PC, student PC at home. And they log into the admin PC, and that will give access to all the instruments that is connected to the same network to the admin PC in, say, their campus or their labs. So, of course, one-time setup is required, and probably the lab staff or the lab technicians is the only one sitting in the lab doing all the coordination. And the rest of them, student can configure freely, measure, perform measurement freely, or even remote control the instrument with the flexibility the software is given. Okay, let's move on. I think we are running short of time. Okay, next I want to talk about a few of teaching challenges, because we know we have a big group of lecturers and students over here. So next, Dr. Ida. Okay, so if you take a look at this diagram, very commonly when I got invited to universities, local universities or private colleges, to be a panel judges for their say FYP projects or FYP presentations. This is my common observation. Student level kind of IoT project development cycle, they will usually start with an idea, then they quickly integrate sensors or controllers to perform a POC. And if they have time to develop PCB, then they will move quickly to electronic design phase, where they fabricate PCB or they 3D print the casing or the mechanical structure, and they develop the firmware, and they call themselves done with the project. But what I want to draw your attention to is what happens after the project. So most of the time, when I interview the students, whenever I have the luxury to talk to them during this, as a panelist during this FYP exhibition or presentation, when I talk to them, like, what happened next? Very commonly, I got answers like, no, I'm done. Next week is my presentation and I'll be graduating. And yeah, I'm done with the project. So if you look at next slide, this is a common IoT development cycle in the industry. Let's take a smart agriculture as a case study. If I want to build a sensor node to measure the humidity of the soil, of course, this is a generic cycle. We start with a schematic design, for example, then we move on to PCB design, we design the firmware, we do functional tests, and then we validate it. We measure the power consumption with a long list of test plans, and then we improve. We repeat this iteration over and over again to make sure the product is bug-free before we deploy to the field. In next slide, Dr. Ida. Yeah. So if we take smart agriculture a case study as an example, we wouldn't want to deploy it in, say, one or two controlled environment, because if we are selling it across the globe, we are expecting our products to be deployed everywhere. So the question is, if we train our students to design their IoT applications in a student-level IoT product development cycle, then there is a huge gap in between completing merely a student-level prototype versus a real productized or commercialized IoT products in a factory. Because these students or electronics and engineers graduates, when they graduate, ultimately they'll be working in factories producing commercialized IoT products to the global market. So we are not talking about building student level IoT projects. Now, the question now is about the scalability. Let us take a look at this very interesting incident I had in the next slide. So the other day when I was not feeling well, of course, this was long ago, long before COVID season. Don't worry, I'm healthy right now. The clinic I went, they implemented this smart queuing system. So once the patients registered at the front desk, their name will appear in this TV. Of course, if you pay a closer look, my name is actually there. And out of curiosity, I walked closer to the TV and I realized something like this. On the right bottom corner of the screen, there's a Raspberry Pi connected to the TV with a big fan, with a big exhaust fan connected to the Raspberry Pi. So now I started to ponder, yes, this is very good IoT applications. They are getting the data from the front desk, they are storing the data probably in the cloud or in local server, and from the server they grab data and they display it on the TV, or we call the dashboard in this case. And they make it a multifunction dashboard. Instead of having the queue on the right hand side, they also have some multimedia. They play some videos on the left hand side to kill boredom amongst the waiting patients in the line. The question I have to myself is this the way I want to train my student to be? If I train my student to build only student level IoT products, can they survive? Can they make money? Can they build projects? Yes, of course, like this is one of them. Probably someone created these brilliant ideas and they supplied it to this clinic. But what if this supplier were to supply this to, say, 200,000 clinics across this region? If you pay a closer look at the diagram on the right bottom corner, I can see dust accumulating on the Raspberry Pi. And that is worrying because we wouldn't know when this dust will be clogging the fan. So stuff like this is something we really have to instill among the engineering students, especially in preparing them to work in the smart factories in the future. So if we go into next slide, Dr. Ida, what we want to study is, yes, apart from training our student to build IoT applications merely for their FYP presentation, at the same time, we have to also expose them to the IoT product development cycle that is happening in the industry. So if you go into next slide, Dr. Ida. So these are some of the common phase the students will be seeing. Of course, the first one of you have to do some market survey. You understand about the market demand. Then you start to architect the IoT products. And you move on to the detailed design where you split the work into multiple divisions, job functions, and each of them will be working parallelly on the design. And then we'll move on to prototyping and validation. That is where we clear all the bugs before we move on to mass production. And once we are done with the mass production, before we ship it to our customer, we go through another round of testing and verification. And of course, the last phase is the deployment and integration. So if, let's say, you are one of the engineering students currently listening to this presentation and you are about to graduate in, say, 1 or 2 years' time. And if you think like, hey, IoT is very interesting, IoT is a trend is the next trend, and I want to work in IoT field, I want to become an IoT engineer. Then let me remind you, IoT engineer probably doesn't exist. So if you type, say, IoT engineer in Google, you probably couldn't find IoT engineer. Reason being, can we hit next, Doctor? Yeah. Reason being, there are multiple job functions to make up this entire IoT product development cycle. Let's start from the very bottom, the box with the dark green color. In order to perform the architect work, to build the big picture, the high-level block diagrams, usually it has to, the guy who is working on this needs to have a very deep understanding of each and every components within the IoT framework. So most of the time, this is done by, say, for example, the principal engineers or the CTO of the company or even the system architect. And move on to the next. During the detailed design phase, this is when, back to the, thanks, Dr. Ida. So moving to the next block, next phase, we have this, this is where the domain expert is required to work in parallel to develop the entire IoT products. So if, let's say, you are graduating students and you want to embark on IoT journey, this is where you can start to be, say, a PCB engineer, PCB layout engineer, schematic engineer, RF engineer, analog engineer, firmware engineer, or even network engineer. And moving forward, we have validation phase. Of course, we have the mass production phase. At each of these phases, different skill set is required. For example, in mass production, factory environment, production environment, we need expertise like statisticians. We need materials engineer. We need automation engineers, or even product development engineer, to make sure the entire production run well, or to make sure the quality of the product before they give a go to a product, to sell or to ship a product. So this is a few key pointers the students like you can start with. So in summary, when we talk about the teaching, the challenges in teaching in industry or the academia, the first thing we were talking about is mainly on how to prepare your student to build a scalable product. So if, let's say, you are done with your FYP project in the future, and if you have plenty of time to spare, try to ask yourself, how can I make my product better? How can I make my FYP project better in terms of, say, the stability, the battery consumption, what is the channel power of the communication protocol, what is the occupied bandwidth, and how can I pack more information? These are the questions you can challenge yourself to improve your FYP project. And of course, the next one, once you are graduating, if you want to work in the IoT domain, try to avoid keywords like IoT engineer, because IoT engineer is a big word. Try to go deep into each of these components. This is where you can start with. I think that's all from my side. Let's move on to the next one. Okay, so to wrap up, Techmark, the company I'm working for, we are the sole distributor to Keysight Technologies. We are a technology company in this region. And my name is Eric. So over to you, Dr. Ida.
All right, thank you, Mr. Eric, for the session, and I'm sure that all of us has been benefited from the webinar. Let's move on with the question and answer sessions. To those of you who are currently watching with us, do type your questions in the comments, and we will do our best to answer all of your questions. So let's pour the comment sections with your questions, and Mr. Eric will be able to answer your concerns on the question and answer sections after this. So yeah, we are waiting for the questions to come in. While waiting, I might have a very simple questions to Mr. Eric. From your practical or your everyday job, do you think that Malaysia are ready to tiptoe in the IoT environment?
Okay, so the question is about whether or not Malaysia is ready. This is a big question. It's not simple at all. So we can, of course, we can take these questions from a few perspectives. And again, these are just my opinion. Let us try to look at the industry. Are we ready? Yes, definitely. Even I myself, I work with some of these local companies, electronics manufacturer, that is developing IoT applications, IoT products, and their products is say is well known, is available to consumer across the globe. So if you think we are not ready, then I think no. The answer is no. We are definitely ready because some of the companies already did it. But if you talk about say in terms of the human resources, the students, are they ready for this IoT? Are they ready to, I mean, the graduates, the electronic graduates, are they ready to work in this industry? Of course, if you talk about the graduates as a whole, there are rooms to improve. So try to, of course, my suggestion to some of the lecturers, if you are streaming live here today, my suggestion to the lecturers will be like what I have covered earlier. Try to close the gap within the students in terms of how to build a commercialized IoT product instead of stopping in a student level IoT projects, merely enough for FYP. That is my suggestion to the lecturers. So webinars like this, or conferences, seminars from industry engineers will be a good exposure to the students to close this gap as well. And of course, we need the support from the government as well to drive this. And of course, our government is doing it. We have a few initiatives, the IR 4.0 initiatives from the government. Those are good initiatives that is making us on the right track. Doctor?
All right. So yeah, I guess you gave a very insightful answer for this. So basically, everyone need to play a role in order for us to move forward with the IoT environment. Okay, we are still waiting for questions. Okay, we have basically a second question from Dr. Tu Ziancha. Can IoT work without the cloud? And is it safe to have IoT in cloud?
Okay, so there are two questions over here. Can IoT work without the cloud? Of course, yes. But if you take a deeper thought, placing your IoT applications in the cloud gives us so much benefit. For example, I can do remote control. I can access my data remotely, regardless of where I am, because I store the data in the cloud. And the other benefits I can think of for storing IoT data in the cloud is that we can have basically unlimited number of resources, the storage, because the capacity is actually expandable easily. So if we were to apply IoT applications without the cloud, yes, it is doable, but we may lose the benefit of having the cloud. And is it safe to have IoT in the cloud? Okay, so so earlier on during the webinar, we discussed a few challenges like the denial of services, the man-in-the-middle attacks. Those are the real security threats we are actually facing. Whether or not it is safe, I would say at this moment it is good enough, but it can be better. There are times when we think, okay, saving our IoT data in this well-known cloud is safe, but every now and then we hear incidents or data leaks, news about data leaks that is worrying us. So I think yes, we can definitely do better. Okay, doctor.
All right. So we will take another 2 questions. Please type your questions before we end our Q&A sessions. Okay, so I guess we have another question from Shirin Moster. The question is that, can IoT be applied to countries with very slow internet connections? Over to you, Mr. Eric.
Okay, thank you for the question. I think it is quite similar to previous question when so if you look at the IoT framework or the IoT ecosystems, when we talk about the 5 core elements, the one needing the internet connectivities is actually the connection to the cloud, the path to the cloud. So if let's say you are applying this to countries with very low internet, very slow internet connections, probably you can have local service, but again, you may lose the advantages of having a cloud. Okay.
Right. Is there any other questions? Okay, the next question from Falcon 360. How much programmers are influencing in IoT projects or in IoT future? Over to you, Mr. Eric.
So how much programmers are influencing? I'm not sure if I get the questions correctly. So if let's say we look at the entire IoT ecosystems, I would say yes, no doubt. Programmers play an important role because we need engineers, programmers to write a good firmware. For say battery consumption concern, we need good programmers to write IoT applications like Android app, iOS app, or web app. But the programmers are not the only contributors to the entire IoT ecosystems. We need electronics engineer, for example. We need RF engineers. We need QA engineers. We need all sorts of engineers. So moving forward, so let us put it this way. In the past, when say 5 years ago, when we were just starting to talk about IoT, then probably we can segregate ourselves, or we can put a clear line in between conventional electronic versus the IoT applications. But moving forward, when all the applications are internet enabled, so basically everything is it's IoT enabled. So in that case, we're actually going back to whatever we are having right now. We need analog engineer, we need RF engineers, so not only programmers. Okay, doctor?
All right. I think that's the last questions for today. And on behalf of our participants, I would like to thank Mr. Eric for a very wonderful sharing sessions. And we hope you will be able to share more information to our students and to our colleague in SEGI in the near future.
Thank you so much.
All right. All participants, we have an upcoming webinar titled Future of Jobs, Digital Marketers, YouTubers, KOL, Social Influencer, and more that will be happening on the 27th of June 2020. If you see yourself as a future digital marketers, YouTubers, social influencer, you are more than welcome to join us. Please scan and go to the link now to register. Okay, there are also a link provided in the descriptions below. If you do not want to miss any of our upcoming sessions, you can also subscribe with us by joining our Telegram group. Please scan and go to the link now to join the group. You can also find the link in the descriptions. We have come to the end of today's sessions. On behalf of SEGI Group of Colleges, I thank all of you for joining our SEGI Evening School webinar today. Stay connected and see you next time. Thank you very much.